24 hours have passed, growing our community. We're excited to have you join us today for Andy Yoon's session, Every Byte Counts, What Data Type Choices Matter. This 24 hours of past event consists of 24 consecutive live webcasts delivered by up-and-coming speakers and experts from the past community. All sessions will be available next week on demand on 24hoursofpast.com. My name is Vicki Van Dam and I'm the Operations Manager for PASS. I have a few quick introductory slides before I hand the reins over to Andy. He will then speak for about 40 to 45 minutes and we'll then move on to Q&A where you can ask any questions that you may have. Next slide please, Andy. If you require any technical assistance, just type your question into the question pane on the GoToWebinar control panel and I will assist you. If you have any difficulty seeing what is being presented, you may use the Zoom button located at the top left of the presentation window to zoom in or out. The question pane is located on the right-hand side of your screen. Feel free to enter your questions there at any time. Once we get to the Q&A portion of the session, I'll read those aloud to Andy and we'll get through as many as we can. Also note that there will be a short evaluation at the end of the session. Your feedback is important to both us and our speakers, so please take a moment to complete it. It will show up on your screen as soon as the webinar is over. Next slide, please. I'd also like to take a moment to thank our presenting sponsors, Microsoft, Cisco, and Dell Software, and our supporting sponsor for the event, SQL Sentry, HP, and SolarWind. 24 hours of PASS would not be possible without their support. They are the reason that this event is available to our community free of charge. Next, I'd like to bring your attention to the upcoming PASS Summit. Next slide, please, Andy. Taking place in Seattle, Washington from October 27th to 30th, the PASS Summit 2015 will feature over 200 sessions with world-class SQL Server experts. Planned and presented by the SQL Server community for the SQL Server community, PASS Summit is single-handedly the largest gathering of SQL Server and BI professionals in the world. With over 5,000 attendees from across the globe, the PASS Summit is also a great place to network and meet face-to-face with expert peers and MVPs. More importantly, PASS Summit delivers on providing you with the answers to your SQL Server challenges along with the knowledge, strategies, and skills you'll need to stay ahead of the curve. Optimize your savings by registering before the end of Sunday, July 12th, and you can also connect with your local chapter for a discount code to save $150. To find out more about the event, please visit www.passsummit.com. Next slide, please, Andy. Now I'd like to introduce the speaker of the hour, Andy Yoon. Andy is a SQL Server architect and developer who has worked with SQL Server since 2001. Andy volunteers with PASS as a chapter leader of the Chicago Suburban User Group. He's also presented at SQL Saturdays. In the Simple Talk 2014 Tribal Awards, Andy was a runner-up for Best New Community Voice, and in May of 2014 he was recognized by Grant Fritchie as Speaker of the Month. If you'd like to connect with Andy after this session, you may do so via his blog, email, or via Twitter and LinkedIn. His accounts, which are all up on the right-hand side of the screen there for your reference. And without any further ado, please allow me to present the speaker of the hour, Andy Yoon. Take it away, Andy.
Thank you very much. Hello, everyone. Welcome to 24 Hours of PASS, and welcome to my session, Every Byte Counts, Why Your Data Type Choices Matter. I got a lot of content in here, and we have a limited amount of time, so let's dive right on in. So when was the last time you took a look at a brand new database? Maybe you started a new job, maybe you purchased a new vendor app, and you kind of started looking around and you saw some data types that just didn't look quite right. Sure, you know, first name can be stored in a varchar 255, or you could store a zip code in an integer, but you know, some of these data type choices just didn't sit right with you. But maybe you didn't know exactly why, or you know, it could give a good solid technical explanation why. Or have you ever had to field the question, why not just use, you know, NVARCHAR and varchar max all over the place? Or why can't we just use BIGINTs and decimals everywhere? What's wrong with that? Well, hopefully after this next hour, I can arm you with some of the real answers and provide you with some insights as to how SQL Server really stores data records and what are some of the consequences of your data type choices, and actually give you some tools so that you can actually take some of my scripts that I'll be presenting in some of the demos and actually look at your own systems and see, hey, wait a minute, what's really going on here? Oh, maybe there's a couple of things here that I can do to improve the performance of my own system. So, first chapter, internals. How is data stored? I'm a big fan of SQL Server internals, kind of like how a automobile mechanic would learn the ins and outs of a automobile engine just to squeeze a few extra horsepower out of it. I'm a huge fan of SQL Server internals and learning, at least having a good working knowledge of SQL Server internals and the storage engine, just so that we can squeeze that much more horsepower out of our queries and out of our storage engine performance. So let's talk a little bit about how data is stored. So for the first portion of our presentation, we're going to be looking at this employee table. This employee sample table that we have here stores a number of different data points, pretty typical kind of data points that you would find in any kind of enterprise. Let's pretend for context that this is a US-based company. So we have things like social security number, we have title, salary, the day that you're hired, and we also have some breadcrumb columns like the record created date, record last modified date, et cetera, et cetera. So the first question that I would throw out to you guys to ask yourselves is this. When you declare this table, does SQL Server actually store and serialize the columns, the data points, in the order that you have actually declared them here in this create table statement? The answer to that is no. SQL Server will actually reorder them to some extent and store them in something called the fixed var format. Fixed width data types come first, and variable length data types come second. So here's actually a list, a shortened list of some of the fixed width data types and some of the variable width data types. To be perfectly honest, when I first started working with SQL Server, I didn't really think too much about this, and I never really thought about, hey, this might be fixed width and this might be variable width, and what the consequences of that might have actually been. And one of the consequences in this particular case is that with a fixed width data type is that no matter what value you store within that data type, it will consume that much space. So therefore, if we have an integer column and we store the value 0, 100, or 2 million, or even null, it will always require 4 bytes of storage. So a couple of interesting things that I'd like to point out in this particular slide is notice that with the CHAR and NCHARs, along with the VARCHAR and NVARCHARs, we have an additional multiplier, a ×2. For NCHAR and NVARCHAR, that multiplier is because SQL Server is able to store Unicode information within the NCHAR and the NVARCHARs. But if you're only storing information that's ASCII-based, the US alphabet, if you will, then you only need to use CHAR or VARCHAR. Otherwise, you're incurring twice the amount of storage overhead. Another interesting thing to point out is with both VARCHAR and NVARCHAR, there's an extra 2 bytes of overhead. I will talk about what those 2 bytes of overhead are shortly. However, that's something to keep in mind if, for example, you're storing something that is really, really short, say a single letter code. So in that case, you may just want to go with a CHAR 1 for 1 byte of storage as opposed to a VARCHAR 1, which will cost you 3 bytes of storage. Something to keep in mind. So let's take a closer look at the fixed var format itself. So as we see here, the first 2 bytes are just some tag bytes. They have a handful of status bits. And then after that, we have F size, the total fixed length size of our record. And then after that, we have the actual fixed length data. And then we have the number of columns, total number of columns in this particular record. And then we have something called the null bitmap. This is a little interesting. SQL Server, in order to serialize and store null, uses this little trick such that for every single column, regardless of whether it is nullable or non-nullable, 1 bit is serialized here and representing and is used as a shortcut, if you will, to figure out whether that value is actually null or not. So when you're doing an is null check, for example, or a query that uses is column X null or not null, it'll actually go to the null bitmap first. It'll check that bit for that particular column, and then it'll move on. It's actually an interesting little optimization that the SQL Server engineers put into play. Now, something to keep in mind is that if your record only has fixed width columns, then your record is done here. There will the var count, the var offset, and the var data will not be present at all. But if we do have some varchars or nvarchars, then those will be present here. So let's dive in a little bit more deeper into the fixed length size columns, and then we'll look at the variable length ones. I'll show you a few examples. So fixed width columns, let's pretend that we just have these 5 here for sake of simplicity, and then we have this theoretical data record. So, with employee ID, gender, social security number, manager ID, and date hired, no matter what the values are being stored in here, it will consume 144 bytes, broken down in this particular fashion. Because this is fixed width, again, keep in mind that no matter what, we're always going to be using the space. Variable width, that's where we get a little bit more interesting, if you will. Remember that extra 2 bytes of overhead per variable, per varchar or nvarchar? That shows up here in the var offset. Because what SQL Server needs to do is that it needs to be able to do the math, and it needs to know the actual length of the value that you are storing in that particular column, so that SQL Server can essentially do the math, so that if you know that you're querying for title, it can immediately just jump here, or if you're only querying for email address, SQL Server can do the math and then jump here. So notice how this particular record, president and al at countingbytes.com, has a certain set of lengths, but then this next record has 2 different values for the offsets because of the values that are actually stored within the record. Same goes for this third example. We have this intern, 12, and then Isabella at countingbytes.com, 52. So hopefully you can see a little bit more about how the variable with records can differ a little bit. So going back to employee large, if nothing else, we know that one thing that we can derive from looking at employee large is that because of the fixed width data types requiring a minimum amount of, or always requiring the same amount of storage no matter what, we can derive the minimum amount of storage that one single record from employee large will need. And in this case, that value is 1,300 bytes. 1,300 bytes may not sound like a lot to you, but the thing is, I argue that we can do better, much better. How? By using a technique that I like to call right sizing. What do I mean by right sizing? When I talk about right sizing data types, what I mean to say is that we want to try and choose a data type for each of our different columns that fits as best possible, if you will, but yet scales to our actual needs. Instead of just being, instead of just throwing around ints everywhere, do we actually need to store, or will we ever actually have values that go up to 2 billion whatever for an integer? Are we ever only going to store a few dozen values for that particular data point? Then yes, we can absolutely use a tiny int. Or again, for example, people use date time all over the place, but do we actually care about the time in a particular scenario? These are the types of things that you need to ask yourself as far as your business is concerned, as far as your application is concerned, and as far as your data is concerned. There is no right answer, general answer I should say. There's only a best possible answer for your specific scenario. So that being said, let's do a little exercise together. So first of all, we have social security number. It was originally set up as an NCHAR 50. I would say out of the 3 options, date, number, or string, which one would you choose? Think about that for a moment. In this particular case, I would suggest that we go with a string. And again, let's pretend that this is a US-based company. We don't have to worry about internationalized values of any sort. So of the 4 string options here, which one would you choose? Think about that for a moment. My answer would be CHAR 9. In this particular case, I'm going to say that our application, our consumer, can add on the extra dashes, if you will, for formatting purposes. So I just want to store the raw values. And because of social security numbers, always 9 characters long, really 9 digits, I decided, you know what, I'll go with a CHAR 9 in this situation. However, if again your company or your scenario is one that you have international, say, IDs to store that are longer than this, then you'll want to make a different choice. But that's all part of right-sizing, is asking yourself these kinds of questions. Let's do a second example real quick. Vacation days remaining, integer. How many people out there have 2 billion, however many days of vacation? If you do, let me know. I want to work for your company. Otherwise, what are the 3 types would be appropriate for vacation days remaining? Date, number, or string? In this case, I would suggest a number. So here are 3 options for you: tiny int, small int, and decimal. Now, many people might be thinking, oh, tiny int, that's just fine, because I mean, who's going to have more than, a couple hundred vacation days? Or some people might say small int, because with tiny int, you can't go negative. Can any of you actually borrow against your current year's allocation of vacation days? I can. However, in my company's case, I can also take partial vacation days. Additionally, I will actually accrue on per pay period 1.6 something or other vacation days per pay period. So for my system and my company, a decimal is actually the appropriate answer. But hopefully you get an idea of what I mean by right-sizing, is that you need to ask yourself these business questions, these application questions about your application, your scenarios, to figure out what is the best, most scalable answer for you. So, having gone through this right-sizing exercise, let's look at our employee table again. And this time I've created a second one called employee narrow. You see that I've made a number of different changes. For example, I removed the unique identifier and replaced that with a GUID for our clustering key and primary key on employee ID. I've made some other changes, such as on date hired. I've changed that to a date data type, because the thing is, we don't care about the time. It used to be a date time. I don't care about the time that you were hired. We've changed things like record created date, record last modified date to small date time, because I don't care about that millisecond precision. You may in your scenario, in your environment. I'm going to pretend that in our case we don't. In either case, with all these different changes that we've made, how much minimum storage does one of these records in employee narrow require? 104 bytes. You guys remember how much storage at minimum was required inside the other employee table? 1,300 bytes. That's a huge difference, a big factor of 10. Amazing. Pardon me for a moment. All right. So moving on from the fixed var format, I'm going to talk a little bit about data pages, because in SQL Server, SQL doesn't actually store all of these data records all serially on disk. It uses yet another container, if you will, something called a data page. Let's take a look. So there are 3 types of data pages. There are other kinds of pages in SQL Server, but when it comes to data pages, there are 3 types: in row, row overflow, and lob. All pages have a fixed size of 8 kilobytes, and this is a point that will become very, very important. And every single data page is comprised of 3 simple components. The page header, 96 bytes. That's always there, and that stores a number of different data points about your particular page, and that's essentially space that's lost to you from a storage perspective. And then we have data records, and then we have something called the record or the slot array. For every single record in this particular data page, there will essentially be a pointer to where the data record is stored. If this particular table that we're looking at is actually a clustered table, then it is within the record or slot array that SQL Server actually enforces and stores the ordering of all your data records there. In the data record portion of the data page, your records are just thrown in wherever there happens to be room. So when SQL Server actually comes to look for data records, it'll come here first, find that pointer, your clustering key, and then that will jump to a data record somewhere out here. So the 8 kilobyte limit. This is very, very important, because all I/O in SQL Server is not done on a record-by-record basis, but on a page-by-page basis. Even if you do a select one or a select top 1 record from a table, you're not going to pull back just 1 record. You're going to pull back a data page full of records. So if you start thinking about these data pages as containers, it's in our best interest to try and maximize the number of records that can be put into one of these data pages. And I'm going to kind of show you that over the next couple of slides. A few other things of note, row overflow data pages, that's where, varchar 8000 or NVARCHAR 4000 data records are values are placed. And then lob data pages, varchar max and NVARCHAR max. With with the two maxes, what'll happen is that if SQL Server can fit your particular data value in, on the base in-row data page, it will leave it there. However, if you exceed the amount of free space that's available to you in that data page, then SQL Server will replace that little portion of it with a pointer, and then that pointer will then go out to that lob data page, which will then store the actual varchar and varchar max data values. Something to keep in mind, because the thing is that requires additional I/O. Now instead I have to go to the base page, and then I have to go out to this row overflow or lob page. Additional I/O, additional overhead. One reason why you don't necessarily want to use maxes everywhere unless you actually have a need for it. Something to keep in mind. So how many per page? Let's think about or look at our employee large and employee narrow table. So at minimum, knowing the minimum record size, we can quickly do the math, and we can see that per data page, at best, we can store 6 records per page. And there's some wasted space there as well. Not much we can really do about it. However, if we look at employee narrow, I can store a whopping 77 records per page. This is a heck of a lot more efficient. I can put in a lot more records into this one same little bucket. Let's look at it from a different perspective and kind of hopefully to show you, why do we really care? Let's say I were to execute this particular query, select first name, last name from employee narrow, blah, blah, blah. You see that I have to pull a handful of data pages here, right? Nice little cute visual, I hope you enjoy. However, if I were to do the same query against employee large, oh, hey, wait a minute, I have to pull out a whole bunch of other data pages now in order to get that same exact data. This is additional I/O. This is additional work that SQL Server must do solely just to get the same data. What's the difference in numbers? Some people like looking at numbers, so here's some numbers that we can look at. Now, earlier we were talking about, differences in bytes, but the thing is, who actually has systems or tables that's just one record in size? But seeing it with, 1.5 million or 25 million, we can see that the size difference is tremendous. And this helps you out not only on pure storage, but whenever, say for example, if you need to table scan that table, all of those data pages must then be consumed. That's a heck of a lot of I/O that must happen. All that data must come through RAM into your buffer pool, if assuming it's not already in your buffer pool. It'll consume space within RAM, and all of that must be processed. It's all additional I/O for the same exact number of records. So transaction logging. I want to talk briefly a little bit about transaction logging as well when it comes into performance considerations, if you will. So all insert, update, and delete statements require writing to the transaction log. And the question that I throw out to you guys is, does the record size or the data type choices that we have within our record impact how much transaction log gets written? I'm going to show you in a demo shortly that the answer is yes. And keep in mind the consequences of larger transaction logs. It means longer and larger backup operations. It's more work that SQL Server has to do because, for example, if you run that update statement, in a highly transactional environment, if you have to write a lot of transaction log for that particular update statement, that's even more work that SQL Server has to do behind the scenes if, for example, you just have inefficient data type choices. So that being said, let's jump into our very first demo. I'm going to go over a handful of different things that will that hopefully will be of use to you guys. One moment, please. Sorry, I'm on the tail end of a cold here, but hey, the show must go on. All right, let's jump into our very first demo. I have a database out here called Every Byte Counts. I'm going to make sure we're using that. And then I'm going to query my employee large and my employee narrow table just to show you that we have the same exact data here. You see things differ a little bit because, for example, I replaced goods with internal IDs, but otherwise we have first name, last name, gender values, other IDs and whatnot, etc., etc. So how do we get a quick overview of this particular table? Well, you can use the built-in function SPHelp to find out some information quickly about this particular table. Executing SPHelp against employee large, I see that, for example, this second result set here actually shows us all the different data columns. It even shows us the data length here. Keep in mind that this is actual data length. This is a NCHAR 255, but its data length is 510 because of the additional overhead that's required. If this table had an identity column, that information would be here. And if you scroll further down, you'll have some other interesting pieces of information, such as whether there's any indexes, any constraints, foreign keys will show up, and whatnot. Again, let's look at employee narrow real fast. We'll do the same thing there. A lot of really useful information. Hey, we see that this particular table has an identity, seed 1, increment 1. All right? This is really kind of useful, but who here wants to type exec SPHelp all the time? I sure don't. So instead, I love to use keyboard shortcuts. So if I go to Tools, Options, Keyboard, and Query Shortcuts, you can see with Zoom It that there's actually a number of different query shortcuts that you can set up within here. Alt F1 and Control 1 and Control 2 are already built into SQL Server. I like to use the control key, so I've mapped Control 3 to SPHelp, and then you can see I've mapped some other commands that I like to use a lot to some of the other control keys. So what does this allow me to do? Well, let me show you. Instead of having to type all this craziness out, I can just highlight employee large. I can hit my keyboard shortcut, Control 3. Boom, I've just executed SPHelp. Now, why would I show you something as rudimentary as that? I'll tell you a quick story. A couple of, around the time that I was developing this session, a colleague of mine had put together a migration script for one of our deployments. And that particular night, of deployment night, it blew up. What that deployment script was doing, or migration script I should say, was that it was taking a bunch of data from an existing table, dumping it into a temp table, doing some manipulation against it, and then pushing it back out. This was all part of our deployment process. In this particular case, that script blew up at 3 in the morning. The reason it blew up at 3 in the morning was due to a truncation error. What my colleague had done was that he had created a temporary table and just set a bunch of VARCHAR 50s. And the thing is, it passed QA just fine because QA runs with a subset of production data. However, there's one client out there that just happened to have some handful of data records out there that were actually larger than the VARCHAR 50 because the column in question, or some of the columns in question, were actually VARCHAR 100s. My colleague never bothered checking or double checking the underlying data types of the table that he was querying from. And in this particular case, we only ran into it during the actual deployment because we didn't have that particular test data in QA. So that's why I like to show this particular little tidbit. And again, who also memorizes every single column, every single little detail about their tables and about their entire database schema? I sure don't. So I use this all the time throughout my workday just to quickly reference things. I also like to do things like, say, for example, if I'm writing an insert statement and I need to grab a bunch of columns, I'll grab them from here, highlight them, copy them out, and then do with them as I will. So that's why I like to show this off. It's a simple little tool, but it's something that I find extremely useful, and particularly for checking your data types. Moving on, I'm going to show you a DMV now, sysdmdb index physical stats. This particular DMV is interesting because the thing is it can show us a number of different data points about our tables. In this particular case, I'm just going to look at employee large. And I'm just going to look at a handful of the columns that are available to us within this particular table. So looking at employee large, we see that the record count in here is 250,000 records. Both employee large and employee narrow are 250,000 records each. We can see the number of pages that this clustered index consumes. We can also see the minimum record size in bytes. You guys didn't think I sat there and actually did the math for that. No, I looked at this DMV and I pulled it from there. Another interesting one, however, is the average record size in bytes. This one will allow you to actually take a look at your existing systems and say, hey, wait a minute, am I actually making very good use of the data types that are out there and given my actual data values that are actually in my table? This is a particular data point that I like to use a lot and I think is very, very useful. Let's run the same query and look at employee narrow real fast. We're going to again see that we have, oh hey, only 4,400 pages as opposed to 40-something thousand pages. That's a heck of a lot smaller. We see our minimum record size in bytes again, and we see our average record size. Again, much, much smaller for the same exact data between employee large and employee small. So the next thing I'm going to show off is something called Statistics I/O. I love using Statistics I/O for performance tuning because the thing is, I don't really care as much about the number of records that a query is returned to me when I'm performance tuning. I care about the I/O, and Set Statistics I/O will show me that, and I love it. So I'm going to show you how to use it. So I'm going to do a quick little select top just 10,000 out of employee large, and then I'm going to switch over to the messages pane. Inside the messages pane, I can see that, oh hey, I looked at employee large. I did one table scan or one clustered index scan in this particular case. This is the number of logical reads that I actually executed. The number of logical reads meaning the number of data pages that I just consumed in order to fulfill this particular query. Let's look at employee narrow. Messages, 181 logical reads as opposed to whatever the other value was that I suddenly just forgot. So this is very interesting and it gets a whole bunch of really cool information. But what if you have a whole list of queries? Let's say, for example, I just run these two together. I go to the messages pane. I got a couple entries here, but I have stored procedures that have dozens and dozens of queries in them, and I want to get an assessment of this, and kind of parsing through this information can be kind of challenging. What's really awesome is that my colleague and friend, Richie Rump, has developed a really, really awesome free tool online website called statisticsparser.com, and I will show that to you very quickly. So here at statisticsparser.com, this is all client-side code. Nothing is ever sent back to Richie or anything of that nature, so you can use this securely. I can copy and paste my information here. I can parse it, and I can see not only a breakdown by query. If, for example, there were, say 30 or 40 different individual statements, there would be a number of different statements there. But then I can also see totals, and I love this. So that way I can see the total I/O of, say, a multi-statement stored procedure. So I can look at both, the maximum logical reads. If I had turned on Set Statistics Time on, then Statistics Parser will also take that information and be able to show you the actual execution times. Phenomenal tool by Richie. Check it out if you haven't before. It's really great stuff. And that concludes our very first demo. I'm going to jump to a second demo real fast about transaction log overhead. And I want to show you a little bit about that. For that, I'm going to be using sysdmtran database transactions. In this particular case, when I execute a select star from it, it shows us a whole bunch. It's actually empty because I have no open transactions on my system right now. But if I wanted to find out more information about it, I can just highlight it, hit my keyboard shortcut again, and I run SV help against it. So I can see, let me change this around. I can see a number of the different, or all of the different columns or data points that this DMV will return to me. I can see that it's a system view, or yes. So in this particular case, there's only one column that really we care about for the purposes of this demo, database transaction log bytes used. So what I'm going to do is that we're going to follow this simple pattern of, hang on, there we go, of beginning a transaction. I'm going to execute a statement, and then I'm going to look at the database transaction log bytes used, and then I'm going to just roll back that transaction. And first of all, I'm going to do a simple select. And I'm doing the select just to validate for you guys that, hey, no transaction log bytes have been written because a select statement isn't doing any DML. It doesn't need to write to the transaction log. So this is 0. That's great. Now let's do the same thing against employee large. We're going to do, or not the same thing, but an update against employee large. I'm just going to do some kind of simple replace statement where last name is equal to Smith. And then we're going to record how much transaction log bytes were used against employee large. 121,000 some odd bytes. All right, let's save that out here. Now what if I execute the same exact update against employee narrow? Now remember, this is the same exact 250,000 records here. Whoa, 13,000 bytes compared to 121,000 bytes, a factor of 10. That's that much less work that SQL Server had to do to run that same exact update statement against the same exact underlying data. Let's look at a simple delete example to show the differences. I'm going to run a delete against employee large, 155,000 transaction log bytes, and then another delete statement against employee narrow. 24,000 bytes, a huge difference, that much savings. And keep in mind, this is just for one particular transaction, one particular statement. But how many people here work with systems that just have one statement running at a time? Ideally, many of us run with systems that run systems that have hundreds or thousands of transactions running all at once. We need throughput. We need as much performance as possible, and therefore reducing the amount of work that SQL Server must do to execute a particular command, including reducing our transaction log overhead, will help us in the long run. All right, back to the slides. So I've talked a lot about structure and whatnot, or schema, things, internal structure and whatnot. So I want to talk a little bit about T-SQL now and implicit conversions. Implicit conversions is another hidden performance killer within T-SQL that it has a direct correlation to your data type choices. So alike or not alike, we have variable 1 and variable 2, and variable 1 and variable 2 could store some of these different values. To us, reading them, this is a string and this is a string are identical, or 5 and 5.0 are identical values. We know and understand that. However, depending on the data type that each variable was declared as, whether variable 1 was declared as an integer versus variable 2 was declared as a decimal, or date versus small date time, these two things are not alike to SQL Server. Because of the different data types, SQL Server cannot compare them on a one-to-one basis. It must do what's called a conversion. And when SQL Server converts data types, it follows something called the data type precedence chart. And this is a condensed version of it. And what happens is that the lower of the two data types from the chart must be up converted to match that of the larger one. So therefore, if we had an integer and a big integer, the integer must then be up converted to match that of the big int. So let me show you that in action. One moment, please. All right, demo. Implicit conversions. I'm going to set statistics IO on, set no count on. We're also going to turn on execution plans. So our first simple example here, I'm going to declare my small int as a small int, my big int as a big int, same values of 5, and then I'm going to run two queries. My small int is equal to my small int, and my small int is equal to my big int. And let's see what happens. In this case, I'm going to look at the execution plan. In the first case of the matching types, I'm going to, in this case, look at the filter. Hovering over that, start expression predicate at the bottom, you see my small int is equal to my small int. No problems. You see that there's actually a slight cost difference here. The reason for that, when we look at the filter operation in this particular case, hey, check it out. Ooh. We had a convert implicit operation here. My small int had to be converted to big int in order to match my big int. In this particular case, because they were both variables, the overhead is relatively small. Let's take a look at varchar and NVARCHAR. We have a similar scenario where I have a varchar 50 and NVARCHAR 50, and I'm going to compare them in the same way as I did before. Let's look at the execution plans. In this case, we see a similar behavior. In the filter for the filter operation for the matching data types, everything is good, no yellow flags. In the filter operation of the mismatched data types, I see that, hey, a convert implicit has occurred between my NVARCHAR and my VARCHAR data types. The my VARCHAR had to be up converted to the NVARCHAR. So let's see this with querying against an actual table. So we're going to use employee narrow, and I'm just going to create a covering non-clustered index to help us out. So that non-clustered index will be last name, employee ID, salary, date hired. Okay. Just to show what's in the table real fast, we have, here's all the distinct last names. We have 2,300 different distinct last names, and these are the number of times that they occur. Just a simple, quick way to show you kind of what's in our table. So first of all, I'm going to run this particular query with matching data types. In this particular case, oh, wait a minute, what was my data type? Let's take a look. Employee narrow, control 3. Okay, hey, I'm using my shortcut again, last name, varchar 100. Okay, sounds good. So we have a varchar 100, so I'm going to look for last name matching is equal to Smith. Let's see what happens. In this case, our execution plan. Hey, we have a very nice index seek. We're using the non-clustered index that I created a short while ago, and this is a really nice low-cost query. Yay, I love it. So let's look at a query with a larger data type. In this case, last name NVARCHAR. What happens here? Execution plan. Hey, we have an index scan, and this, over the select operator, we see that we have this little yellow warning. Hovering over that, let's look at the warning. Warning, type conversion and expression. We had an implicit conversion. So what happened in this particular case is that because the last name column inside employee narrow was a varchar, and it was being compared against a variable that was an NVARCHAR, the smaller of the two had to be up converted. What that means in this particular case is that SQL Server had to do an index scan on employee narrow and convert every single value, every single last name from a varchar to an NVARCHAR. A heck of a lot more of a costly operation because now I have to convert every single last name value, and then and only then could I do the comparison. Terribly costly. Let's query with a smaller data type. I'm going to use a CHAR 5 against last name. Let's see what happens. In this particular case, we get an index seek again. And if we actually look here, there's no mention about a conversion. What gives? Well, actually, what's interesting about that is that, as you can see from my note, conversions between CHAR and VARCHAR actually happen to be free. And conversions between NCHAR and NVARCHAR, the conversions are also free. So in this particular case, we lucked out. We dodged a bullet here because our data point last name is a VARCHAR, and we were using a CHAR against it, we were good to go. We didn't have to convert. So let's query with a larger, quote, free data type. Index seek again using that varchar 500. All right. So hopefully you can now see a little bit about how implicit conversions can also burn you. And if we go back to the slides, now here's the thing. Does anyone want to actually go through all of their code and look at all the execution plans in order to find implicit conversions within your current system? Thankfully, you don't have to, thanks to Jonathan Cahias of SQL Skills. He's done the work for you. If you go check out this particular blog post, or you just search on SQLskills.com, Jonathan Cahias, implicit conversions, he's actually written a bunch of code that will go into your plan cache, will shred the XML, and will actually find plans that have been cached in your plan cache that actually contain implicit conversions. So depending on the nature of your system, that will hopefully help you to find a good number, if not many, of your different implicit conversions that may be happening in your code today. So this is a fantastic tool that's out there. Go check it out. So I'm going to wrap up here, and I'm going to leave you with a handful of suggested best practices. Right-size your data types. I encourage you guys to really, whenever you're designing or new tables, or even writing new stored procedures, writing new code, declaring variables or using temporary tables, etc., to right-size your data types. Think about it and ask yourself, how large does this data type need to be? Sure, you may need some room for scaling in the future, but try and pick at least a reasonable size container, if you will. Remember the 8 kilobyte data page size limit. I can't emphasize this enough. This is the core unit of work, if you will, that SQL Server does whenever it does any I/O. So you've got to think about that particular limitation, if you will, or that particular constraint when you're considering performance and writing your queries, et cetera, et cetera. So that's something to keep in mind. Match your data types, please. Implicit conversions can really, really, really burn you. And finally, just try and be mindful of internals related performance impacts, such as the transaction log overhead that I showed you before. Just because you're not necessarily seeing that there's a performance impact, there's other things that are happening behind the scenes that you may not be conscious of, but simple choices such as your data types can have an adverse impact on the performance of your system, as I showed you. And with that, are there any questions?
Thanks very much, Andy. We do have a couple of questions.
All right.
When you use NVAR or NCHAR types, should you always use the N, this is a string format, or does the N indicator not really matter to SQL?
So the N indicator, when you're actually putting that in front, will actually tell SQL Server that that string, if you will, is of Unicode. So otherwise, what happens if you don't do that and you're assigning that particular value to a variable or whatever, then SQL Server does the implicit conversion there essentially. So you may as well be explicit.
Okay. And the next question is, what is the space used by a decimal? For example, decimal bracket 28, comma 14 bracket.
So I don't have that formula memorized. It actually depends on the values that you put in there for both scale and precision, and that's something that you can just look up on books online. That's one of those little bits of trivia that I don't keep memorized. I just look it up on books online whenever I need it. So unfortunately, I do not have that answer off the top of my head, but it does change depending on the scale and precision values that you choose.
Great, thanks, Andy. Unfortunately, some ORM tools love definitions like col gender and NVARCHAR bracket 256. Any experience on dealing with it?
I have a lot of experience dealing with ORMs, and those of you that know me are probably chuckling right now. The thing is, I don't know what your question necessarily is. I mean, what I would say is that go to my contact information, drop me an email, and I'd be happy to provide as many insights as I possibly can to your specific scenario. Things that I can't really answer right now in the time span of a minute or two.
Andy, can you remind us what your website or your blog URL is?
Yes. In fact, I will just go back to the earlier slide, and
Great.
that might be easier.
And the next question is, thank you, Andy, which is better to use between decimal and float?
So personally, I hate float because float is imprecise. Now, I have a background working in the financial industry, so we need precision there. So that is why I personally hate float. I have very little reason to ever use float, so therefore I personally dislike it. If there are use cases for float, sure, then maybe it'll be useful for you, but I have yet to encounter one where I'd rather just use a decimal and be sure of precision. Anything else? You're on mute if you're there.
Yeah, it helps if I unmute myself, doesn't it? Yeah, I'm here now. What is the best type for lob data?
What is the best type for lob data? var binary. Yeah, it should be var binary nowadays. Is the go-to. I very rarely ever have to use lob, so that's something I don't encounter too much.
All right, awesome. And Mike's wondering, how does implicit conversion convert string to int?
So if we go back to the slide with the hang on. If we go back to the data precedence slide, can you repeat the question? It was from string to int?
Yes.
So what happens is that SQL Server will take that string and it will attempt to turn it into a numeric data type. And I'm sure many of you have actually encountered the SQL Server error where if that string is not a numeric value, then SQL Server will actually throw an error. And I can't remember the error, but it's something that's haunted me many a times when I've had bad data. You can simply, you can probably just whip up a quick little prototype in SSMS right now if you wanted to, but essentially, if that string is of a numeric data type, then yes, SQL Server will convert it if at all possible. But if it's not, it will throw an error. Same goes for
Great.
date too, if you're going to have to go from a string to a date value.
Okay, and is the conversion between int and numeric, quote unquote, free?
Nothing is ever free in SQL Server, so no, because the thing is it's still CPU overhead, it's still a conversion, regardless of whether they're similar numeric values or not. A conversion is still a conversion.
Great. Well, the last question is the sample code available on your blog?
It can be available on my blog. I will be glad to put it out there. There's also older versions of this presentation that will be available or that are available at SQL Saturdays that I presented at. But yes, I'll definitely write a blog post real fast to also put a copy of all my demo scripts out there for you guys, because I wasn't sure if that's something that you included with the past site or not.
What we've got on the past site at 24hoursofpast.com is a PDF of your PowerPoint presentation. So anyone who's interested in seeing that, they can go there. And I mean, Andy, we could also post a secondary document.
Okay, in that case, I'll just send it to you guys so it's all in one place.
That sounds great.
Okay.
Well, Andy, thank you very much for a great session, and attendees, thank you all for joining us today. I would like to take one last opportunity to thank our presenting sponsors, Microsoft, Cisco, and Dell Software, and our supporting sponsors, SQL Century, HP, and SolarWinds, without whom we could not bring this great event to you. We hope you enjoyed this session and that you will follow along for the rest of the day. On Twitter, follow us at Pass24Hop and share your thoughts using hashtag Pass24Hop and hashtag SQLPass. Stay tuned for our next session, which will be starting at the top of the hour. Rethink your ETL with BIML, and that's with Chris Schmidt. So thanks again, everyone. Thanks again, Andy.
And thank you, everyone. I hope you had a great time.